So on my device, looks like I've gotten the special IP version 4 address. The apps on the phone that don't support IPv6 are fooled into thinking they're using IPv4.
They're full. If the service doesn't support v6, they're fooled into thinking that they can do v6, but the kernel, the operating system itself, will handle translating that into v6, so that the client just thinks it's just working. And so far, most users don't even recognize it. We've had to put up in our front of house knock questions. What is 192.0.0.2? Get people talking about it, asking questions about it.
Hey everyone, it's David Bumble back with Joe. Joe, great to have you back on the show.
Great to be here.
So Joe, this is not the normal place where I do interviews. Where are we?
We are at Cisco Live in Amsterdam at our Network Operations Center. So one of the things that we love to do, we being a huge team of very excellent engineers, is to come to Cisco Live very early.
Yep.
We've been here for 2 weeks now, and we set up the network that all our attendees, all our partners, all the customers, all the other Cisco employees use. We bring this network in, we stage it first in the Amsterdam office, so it's about 10, 15 minutes away from here. We get it going in early December, so we build out the architecture for the core, for the wireless, for the data center, for the applications we're going to run. We test it all. We play with it a little over the Christmas break, and then we bring it here. We got it here Thursday the 30th, set it up in the RAI, connect it to all the RAI fiber infrastructure in the house, spin it up, and get it ready for all our attendees. We bring in a completely redundant set of equipment. We bring in a redundant core, edge routers, we bring in a redundant data center, and that's because in an enterprise network, you can afford maybe an hour or two, maybe even a half a day of downtime, send people home early. When your event is 5 days and you've got the press and you've got customers, you got partners, you can't afford to do that. So we overbuild build a network so that it has to work. That's the mantra we have here. And then, like I said, we assemble a team. We're about 60 people strong of some of the best engineers across the company who love to do this. We're a little bit crazy since we add, this is not our day job, and we decide we're going to add a little more stress to our lives and come out here and do this.
And you do 3 times a year.
And we do this, this team, we do this in Europe. Our leader, Remco, he kind of does this 3 times a year. He's gotten brought into the global part of the team and does it in the US and helps out in Australia as well. But this is something that, in fact, one of the engineers here makes it part of his compensation package. So his manager has to let him come out here and do this. In addition to all of the infrastructure, the wireless, the world-class wireless we provide with 6 gig, 5 gig for our customers so they get the best possible wireless experience. We provide a lot of applications to monitor this network to ensure that we know what's going on. And if something's not going right, we're able to react to it quickly. So in our data center, we deploy a number of applications like ICE, like Identity Services Engine. We use Cisco Prime Network Registrar for a very powerful, redundant DNS and DHCP solution. We use Umbrella to protect that. We have a security operations center that have a huge Splunk deployment here. They're using secure network analytics. They're using XDR to be able to spot problems with the network. We've got Catalyst Center that's looking after the campus, kind of the wired Catalyst 9K part of the network, as well as the wireless. So we have all those applications running in our data center, and we want to be able to bring all of that capability together so we can understand what our attendees are doing. In the years past, back in my day, people would ask me questions like, what's going on with this and that in the network? Because I like operations. I come from a network management background, which is now all the rage. It used to be, network management. Anyway, I come from that background.
Your age.
So they would ask me questions. I said, I can do better. So I wrote a WebEx bot in Python that would connect to these various tools, and people could ask it a question like, what is this IP address? What is this MAC address? And it would connect to Prime, it would connect to Catalyst Center, and it would get that information. And it turned into a spaghetti mess of regular expressions, trying to figure out what a MAC address is, what a V6 address is, what an IP address is. But this year, my 2 data center colleagues, Yara and Anthony, they decided, Remco said, you have money. We have some budget for you. So they said, what could we get? And of course, their data center background, they said, Yara's in sales. So let's go strong. Let's get the best we possibly can. What can they say? No, right?
Yep.
So she went in and bought UCS X Direct servers, like M7, at that time, top of the line. We bought new Nexus 400 gig switches. We bought 8 L40S NVIDIA GPUs. and said, "Oh, they're going to say no to some of this, and we'll negotiate." They said yes. So now we have all of this GPU power, and we have to do something with it, right? So I said, I hear there's this thing that people are talking about. I think it starts with an A, maybe has an I in it too. I said, I can do something with this, maybe if I have time. So I turned my bot into a generative AI agent.
Oh, wow.
So instead of that spaghetti mess of regular expressions, I wrote this relatively nice system prompt paragraph telling it who the bot is. And I said, okay, now here are the tools. Here are the functions you have access to. Connect to ICE, Prime, Catalyst Center, and figure out what the arguments need to be. And the bot, the generative AI, the LLM, figures out what it needs to call with what functions. And the other night at dinner, I unleashed this bot onto the team, and they beat away on it, and it didn't really break. So it actually does provide, and I'll show you the demo of that. It does provide some useful information from this network.
Is it Olama? Sorry to interrupt.
It's based on Olama. So since we have 8 GPUs, I have a HA proxy cluster, or HA proxy on top of that. So we can load balance across those GPUs and make use of that whole infrastructure. We've been having some fun with that. The other new thing we're doing here this year is we decided, IPv6, it sounds like it's been around for a while, but people really haven't adopted it. So one of the things we wanted to do
coming next year.
It's the year of the Linux desktop or something. So one of the things we wanted to do to encourage more IPv6 usage is this thing called IPv6 mostly.
Okay, what is that? Sorry.
We essentially use dhcp v4 with an option 108 that tells the client, and Apple and Android are supporting this right now, tells the client, you are on a very v6 friendly network. You do not need a v4 address. And if any of your attendees happen, I think by the time this comes out, Cisco Live may be over, but let's say anyone gets on a network like this and you notice your IP address is 192.0.0.2, you're on this network. That's not a real IP address.
Interesting.
That means you don't have any v4. Instead, the client will translate any v4 you have to go to, any v4 only service, translate that to a v6 address, go to that service over v6. It gets translated by NAT64 on the gateway. And because of all of this year we have internally 73% of our traffic is IPv6, 51% of our traffic total to the internet is IPv6. So if you're an IPv4 service out there and you only have IPv4, get on the ball. Clients can support v6 a lot more so now.
But I mean, so on your phone, if I open up my iPhone as an example, or Android device, I would see an IP version 4 address, would I?
You would see 192.0.0.2, and that's to trick applications so they don't freak out and they think, okay, you have a v4 address, but it also means things because it's client-level address translation. You can do things like ping 8888, and it works. How does that work? It's because the client is translating 8888 into a v6 equivalent using a special IPv6 prefix, and then it gets v6 through the internal network translated to v4 at the edge.
So so in other words, when you say the client, you're talking about the device in your hand, like your phone.
The device in your hand, your phone, your laptop, and we'll see more clients support this summer. More and more more and more operating systems are adding this IPv6 mostly support.
So on my device, looks like I've gotten the special IP version 4 address. The apps on the phone that don't support IPv6 are fooled into thinking they're using IPv4.
They're fool. If the service doesn't support v6, they're fooled into thinking that they can do v6, but the kernel, the operating system itself, will handle translating that into v6, so that the client just thinks it's just working. And so far, most users don't even recognize it. We've had to put up in our front of house knock questions. What is 192.0.0.2? Get people talking about it, asking questions about it.
And on the internet side, you've got, you said 6 to 4 gateways, right? Translating.
We have NAT64, so we have public v4 space that the RAI gives us that we translate those internal v6 addresses to where we need to, and then we have native v6 transit through the RAI for everything that's truly v6.
That's great, because I mean, that whole joke about IPv6 is coming, it's coming, but is this the first time that you've had more IPv6 than IPv4?
This is the first time in Europe that we've seen more IPv6 traffic towards the internet than we've seen v4.
But in the US, you've had that previously?
I haven't seen it in the US. I believe, I'm told, in Melbourne this past year at Cisco Live in Australia, they had more. I also help out with the Internet Engineering Task Force, the IETF's network. This last meeting in Dublin in November, we had slightly more v6 than v4 for the first time ever as well. So services are catching up.
So you telling me that you're running this critical infrastructure with an LLM, and people can ask questions to that LLM, and it's giving back proper data, not hallucinating?
It's fun. We can ask it to give it back in pirate speak, to write a poem with the output, but the data is factual because I tell it the tools it's allowed to call. It can't invent stuff. It can't do more. Like I was very careful. I didn't say, here's an API spec. Here's some generic functions to do REST, put, get, post, delete. I said, these are the functions, and I control the code behind the functions. That allows me to be a little bit more careful, and it's a first step.
Delete.
Yes, we don't want to necessarily do that. So this is a first phase, and we're finding more use cases, but we're trying to make it real, and we're trying to make it practical for us.
What's the feedback been from the people using it?
Oh, they seem to really like it.
It's better
fun.
than the spaghetti code that you wrote.
For me, it's definitely better than the spaghetti code, but it seems like people like the creativity of it. I also asked it to respond with emojis when and where appropriate. So it puts emojis into the output, and it does it in Markdown. So when it sends it through WebEx, we get nice bold and italics and things like that.
That's fantastic. What have you got on the screen here? Can you tell us a bit about what we see?
So these are the applications behind me that we're using to monitor. We have applications looking at the security like XDR, secure network analytics, looking at what's going on from a security standpoint, from the data we're piping off the network. We use NetApp. They're a partner for storage, and we're monitoring some of the stats on the NetApp arrays. We're looking at Catalyst Center data so that we get an idea of the assurance, so AI-powered assurance for things like the wired and the wireless part of the network. It looks like we've done 66.97 terabytes of internet traffic.
I was just going to ask you how much traffic. You got to give us some stats, like how many devices are connected. Have you got any cool stats?
We deployed 180 access points ourselves to supplement the RISE 550 or so Cisco access points. The wireless team has worked tirelessly. The deployment, just to get all of that going. The keynote went yesterday flawlessly. They did an amazing job on that. I think we have about 500 to 600 switches that we bring and we deploy to power those APs, to connect our exhibitors. We have, like I said, they're dual redundant core. Each one of our 6x2 12 blades has 1 terabyte of memory each. We have about 1.5 terahertz of CPU capability, and the GPUs are pretty impressive. And the UCSXs are pulling about 10 kilowatts of power combined at the moment.
Because I'm always slow, right? Just to confirm, you got 2 data centers outside.
Two data centers here on site, separated by about 500 meters of my American sensibilities going into universal measurements works. But yes, we do it redundant because it's really got to work, and we have to we have to avoid things like this with our attendees. So we do like to have a lot of fun. So one of the architects here has wired our monitors to this button, so we can do some things to lighten the mood if things get a little too stressful around here.
So, Joe, have you got any cool stories that you can tell us, perhaps? And
we will. Some of we've seen some things every Friday. We get in front of everyone. We have about 400 people registered right now, and we tell the story of what happened, what we did to deploy the network, and what we learned from that. Some of the things we did, some of the things we had to change, some of the things we probably wish we had done a little bit better. Like initially, I had a little bit of an open access list on the Nexus on the data center side. Had to close that. Thanks to the security people for noticing some of that. We had an exhibitor who had a public IP address before and left the HTTP open, so we had incidents. So the things like that. And then there are always challenges with an event network because it's so dynamic, and we try to give the attendees as much transparency as we can, because it's because of this that hopefully they'll never run into those problems, because we're heading them off and helping engineering solve them before they get to the customers.
I mean, it's crazy what you guys are doing in a short amount of time. So how many days did you have, from being able to be here till it being live?
We got here on the 30th. We had it plugged in. So it rolled in around 11 a.m. on the 30th. We put everything in. By 3, we were back in the hotel enjoying some refreshments and accessing things remotely. But that didn't stop there. There were lots of setup to do. The staging is all very automated in terms of the switches and the access points. We have a couple of engineers that have built custom applications to do that. That took a few days to get going. Then the deployment team showed up the following Wednesday. They got trained, or some of them we try to bring in new people every year and return people that can help lead those teams. So they came in on Wednesday and started to do the network deployment. So all in all, it's about a week and a half ahead of time, and then we're live, and we just got to make it work.
I mean, it's amazing that you guys can put such a huge event together in such a short amount of time.
That's the team. It really is. They're great people that spend a lot of time, get a lot less sleep than they normally would. But in the end, I think I can speak for myself. I think it's worth it. I like the additional stress. I'm insane. Thank you.